Hello my dear students. So today we will look the grinding machine, unit number 5, machine tool operation. So this is the basic structure of the grinding wheel. The grinding wheel consists of the abrasive particles, and these abrasive particles are mainly responsible for to remove the material from the any workpiece. Okay, basically the grinding machine or grinding wheel is used to remove the material from the flat surface, as well as which is used for the again resharpening of the machine tools. Okay, so first one is the abrasive is the main particle or main element of the grinding wheel. Second one is the bond. So bond is nothing but the adhesive particles which are responsible for the bond between the two abrasives, so it which holds the different abrasive particles together. So next one is the grit, then grade and structure of the wheel. We will see these different uh, aspect of the grinding wheel next. Okay, so abrasive. So what is the abrasive? Abrasive is a hard and tough substance having the sharp edges. So these abrasive consist of the sharp edges which cuts or wears away material softer than itself. Okay, so any machine elements which is any machine component which needs to be machining, so the material requirement for the cutting tool is harder than the material which we are using for the cutting. Okay, so here it cuts or wears away the material softer than itself. Important properties of the abrasive. So the abrasive particle penetration hardness, it should have the fracture resistance. So no, during the machining no fracture will takes place. Then wear resistance, it should also have the wear resistance property, so that minimum wear takes place during the machining. So there are different types of the abrasive. So first one is the natural abrasive, and second one is the abrasive particle. So abrasive. Okay, so natural abrasive itself consists of the which is obtained from the nature. So the natural abrasive are nothing but the sandstone, which consist of the solid quartz, emery, corundum. Emery or corundum, these both are the same. Next one is the diamond and garnet. So these all are the natural abrasives. Next one is the artificial or synthetic abrasives. So artificial or synthetic abrasives are the man-made abrasives which are manufactured by consisting of the different as per the requirement of the grinding wheel. So they are manufactured to have well defined and control properties of the hardness, roughness and type of the structure. So those according to the requirement of the manufacturer, we will design the grinding wheel. So these the different types of the artificial or synthetic abrasives are Silicon Valley, aluminum oxide. So silicon, no, not Silicon Valley. So silicon carbide is the one of the abrasives, that is the SiC, and aluminum oxide Al2O3. Okay, next one is the bond. So bond plays a very important role in case of the grinding wheel. The bond is the adhesive substance. Adhesive substance is nothing but which is just like the Fevikwik. Okay, which holds the different abrasive grains together to form the grinding wheel, because the grinding abrasive particles are the in the different form. Okay, so they are the very just like the powder form. So uh, which cements or holds. So the bond is abrasive substance which cements or holds the abrasive grains together to form the grinding wheel. Okay, so to form the grinding wheel from the different types of the abrasives, so we require the bond. So depending upon the application, bond imparts the qualities of the hardness or softness to the grinding wheel. So according to the bond quality, then we will designate the grinding wheel is the hard or soft. Okay, the choice or selection of the bond depends upon the accuracy. That of course, so bond is the selection or choice of the bond depends on the accuracy and the required surface finish and the nature of the grinding operation. So accordingly we will select the types of the bond, and that bond imparts the qualities of the hardness or softness again. Okay, so bond is the mainly abrasive substance. Fine. Now we'll see the next. Okay, so these are the different types of the bond. So name of the bond, characteristics, and how we designate the bond. So first bond is the vitrified bond, which having the good strength and high porosity. So characteristics of the vitrified bond is the good strength and high porosity, which is designated by the letter V, capital V. Second type of the bond is the silicate bond, which is the waterproof bond used for the large diameter wheels, grinding of the fine cutting tools, etc., which is denoted by the letter S, capital S. Third one is the shellac bond, which is used, the characteristics are nothing but the thin wheels, high elasticity, not suitable for the heavy duty applications. So this shellac bond basically used for the very thin wheel, and whenever there is no requirement of the heavy duty application, so in that case we can use the shellac bond, and which is designated by the capital letter E. Resonite bond, so which is used for the rough grinding, high speed grinding, so which is again designated by the designation of the bond is the capital B. Next one is the rubber bond. So rubber bond, thin wheels, the character of fine finishing and the polishing, that is nothing but the example, we'll take the example of ball bearing races. So in case of ball bearing races, we require the very fine finishing as well as the polishing. So in that case we can use the rubber bond, we can designate it as a R. Now next one is the oxychloride bond, which is the disc grinders, and again it's less brittle. So oxychloride bond, which is denoted or designated by the capital letter O. So what is the grit? So grit and grit, grain and grit number. So what is the grain and grit number? So grain and grit number indicates the general size of abrasive grains. So while making the any grinding wheel, size of the abrasive grain plays a very important role. So size of the abrasive grains again further applicable for the removal of the material from the, if the size is more, or the if the different abrasives are the placed apart from each other, the distance between the different abrasives are the away from each other, then we can use the this size. Okay, size of grain grit is determined sorting or grading of the material by passing through the screens with the number of meshes per linear inch. So size of the grain grit is determined by sorting or grading. Okay, so the abrasive particles are passed through the screens. Okay, screens with the number of meshes per linear inch. Okay, grain size is denoted by the number of indicating the number of meshes per linear inch, that is 25.4 mm of the screen through which the grain pass when they are graded after crushing. Okay, so 25.4 mm is nothing but number of meshes per linear inch. Okay, I already told that the grain size plays a very important role in case of the stock removal rate and generated surface finish. The selection of the grain size is determined by nature of grinding operation, material to be grinded, material removal rate, surface finish required. So these are the different criteria for selection of the grain size. First one is the nature of the grinding operation. Which type of the grinding operation is required? That is whether it's a less surface finish required or rough operation is there. Okay, material again plays a very important. Which type of the, whether it's a brittle, whether it's a hard material. Okay, material removal rate. Of course, the material removal rate plays a very important role, which determines the machining time required. Okay, and fourth one is the surface finish required. Okay, so all are these are the selection parameters which is determined by the requirement of the grain size. Okay, So now if you see this chart, so these grain size are again categorized by the different sizes. Okay, so type is the coarse type, medium type, fine type and very fine type. If you see 10, 12, 14, 16, 20, 24 size, which is used for the rapid material removal. So it's having the coarse structure, coarse type. Okay, which is used for the rapid material removal. So stock removal rate is more. Okay, next one is the 30. The second one is the 30, 36, 46, 54 and 60, which comes under the category of medium type. Okay, so medium, this type of the grit is used for the stock removal as well as the surface finish both. So in the first case, in the coarse type of the grit, rapid material removal is there, but there is no proper surface finishing. Okay, third type is the fine type. So 80, 100, 120, 150, 180, which comes under the category of fine, which is further used for the less stock removal, high surface finish, etc. Okay, then very fine, fourth one 220, 240, 280, 320, 400, 500, 600, which comes under the very fine category. In the fine category, very high surface finish is required, grinding hard materials. Okay, so whenever there is a requirement of the high surface finish as well as the if anybody want to grind the very hard material, then in that case we can use the very fine grit. Okay, so these are the different types of the grain sizes. So coarse one is the medium one is the fine and very fine. So sizes are also there. Okay, so you can see the different types of the applications required for the different grain size. Okay, grade, what is the grade? The grade is nothing but the relative holding power of the bond which holds abrasive grains within a field degree of hardness of strength is indicated softer grades in low alphabet and harder grades in the high alphabet. It does not refers to the hardness of the abrasive grains. The term soft and hard refers to the resistance a bond offers to disruption of the abrasive. So it is not the hardness of the abrasive grain, which is nothing but the holding power of the bond. Okay, so if you see the grade table, in the grade table it's already mentioned that the softer grades are indicated in the low alphabet and harder grades are indicated in the high alphabet. So very soft grades, so categories are given: very soft, medium, hard and very hard. A B C D E F G, which comes under the category of very soft. H I J K, which comes under the category of soft. Medium, L M N O, which comes under the category of medium. Hard, P Q R S, which comes under the category of hard. And very hard, T U V W X Y Z, this comes under the category of very hard. So very hard, it simply means that the holding power of the bond is good. Okay,